Hello guys, now let's solve this light question. Now we have light enters into a glass prism having a refracting angle of 60 degrees. If the angle of incidence of 30 degrees, that is, the incident ray is parallel to the base of the glass prism, okay, and the index of refraction of the glass is 1.50. So what we have here that we want to find out what is the angle the ray leaving the prism makes with the normal. Now let's analyze, the prism. Now we know that um, now it is a known fact that when a ray of single wavelength of light is incident on a glass prism, okay, the emergent ray through the glass, okay, the emergent ray through the glass appear bent away from its original direction of travel by what we call angle of deviation. So which means that when the light, okay, strikes the glass prism, it emerge bent away, okay, it emerge bent away from its original direction of travel. So, and then what we have here is what is the angle the ray leaving the prism makes with the normal. So which means the ray that emerge, that leaves the prism on the other face, on the second face of the prism, okay, what angle does it make with the normal ray? So let's say let's use this apparent ray to represent the normal ray. Now we have another apparent ray here. So these two apparent rays will intersect at a point. Now remember, we are given the angle of incidence, which is what? 30 degrees. So let's say we have our angle of incidence. Okay, angle of incidence to be what? Alpha 1, and that's what? 30 degrees. Now, can we see that the emergent ray through the glass, okay, the ray which emerge, through the glass, this light ray, okay, it will make an angle alpha 2 with the what? With the what we call the apparent ray, okay, which is entering the glass. So now also there will be another angle here, say angle what? Alpha 3, and we are giving the refracting angle of the glass to be 60 degrees. Now, this is the case of dispersion of light when we have the colors of the different light, sorry, the different colors of white light, okay, refract through different angles of deviation, and we know that the light ray that emerge on the 60 degrees. Now, this is the case of dispersion of light when we have the colors of the different light, sorry, the different colors of white light, okay, refract through different angles of deviation. And we know that the light ray that emerge on the second face of the what? Of the glass prism, okay, will spread out. So when they spread out, they will spread out in the form of a series of colors. So this series of colors is what we call the visible spectrum, because we know that the patch of colors or the band of colors which emerge from a prism when a white light strikes the prism, okay, when a white light strikes the prism is what we call visible spectrum. All right, so we have the first angle, which is the angle which the incident light makes with the prism, and that's 30 degrees. So we now have again the second angle, which is the what? Angle of refraction, because we know that when light passes from air into what? Glass, it will refract. So it will refract, it will refract towards the normal, okay, because a glass is denser than air. So in this case, so the bending of the light is why we have this angle alpha. So this is angle alpha 2. So we need to first find the value of alpha 2. Remember, we are looking for the angle the ray leaving the prism makes with the normal. So the emergent ray makes an angle with the normal ray. But here we have the normal ray, okay, to be apparent ray. No, the dotted line, okay. So the two dotted lines here, they intersect at a point, and the point where they intersect, the angle there will be 120 degrees. The angle will be 120 degrees. So we have the second angle, which is the refracted angle, the angle of refraction. All right, so we're going to use Snell's law. Using Snell's law of refraction. Using Snell's law of refraction. Yeah. So to use Snell's law of refraction, this is a glass. Remember, this is a glass. So which means we have that the refractive index of the glass will be equals to the sine of angle of incidence, which is the first angle. That is the angle which the light entering the glass, okay, the light, okay, which is incident on the glass, okay, makes with the word normal. So we have sine alpha 1. So then we also have sine alpha 2, which is a refracted angle. Now this is 1.5. So this will be sine 30 degrees, and this will be over sine alpha 2. Okay, now, so in this case, we have our sine alpha 2 to be equals to sine, now we know sine 30 degrees is what? 0.5. So we have 0.5 divided by 1.5. Now this is 1.5. So this will be sine 30 degrees, and this will be over sine alpha 2. Okay, now, so in this case, we have our sine alpha 2 to be equals to sine, now we know sine 30 degrees is what? 0.5. So we have 0.5 divided by 1.5. All right, so let's get the value for alpha 2. So the value for alpha 2 will be inverse sine of 0.5, okay, over what? 1.5. All right, so in this case, now we know that when we divide 0.5 by 1.5, okay, we're going to get 0.33. So this will be the inverse sine of 0.33. So let's get the value of the inverse sine of 0.33. Now the inverse sine of 0.33 will be 19.5. So we have 19.45. Okay, 19.45. So this is the angle which the lights that emerge bends away from its original position. Okay, the position, I mean the direction of travel, okay, makes with the what? With this apparent ray, and that's alpha 2. All right. So we have our alpha 2. Now, we have here that this angle is 120 degrees. So we know that we have our refracting and the refracting light, and we have the apparent rays. Okay, the apparent rays. Okay, the apparent rays, they meet, and the angle between the two rays is what? Is 120 degrees. So we have alpha 2 in this case, and we have alpha 3 in this case. So now we know that the emergent ray makes angle, let's say alpha 4 with the normal ray. So in this case, we can have our alpha 2 plus 120 degrees plus alpha 3 to be equals to 180 degrees. So we know the value of alpha 2 to be 19.45, then plus 120 plus alpha 3 equals to 180 degrees. So let's add 19.45 to 120 degrees. That will be 139.45. So alpha 3 will be 180 minus 139.45. Now let's get the value for what is 180 minus 139.45. Okay, so that will be 40.55. So alpha 3 equals to 40.55. So that is this angle. Now, remember, this is the refracted ray. So to calculate the value of alpha 4, this angle. Okay, so we have that alpha 4, okay, is the angle the ray leaving the prism makes within 5. So that is this angle. Now, remember, this is the refracted ray. So to calculate the value of alpha 4, this angle, okay, so we have that alpha 4, okay, is the angle the ray leaving the prism makes with the normal, is equals to angle which the ray leaving the prism makes with the normal, yeah. So in this case, so it means that the refractive index will now be, since we have emergent ray, okay, so the refractive index will now be sine of the unknown angle divided by sine of this angle, which is what, 40.55. All right, so we know that the index of refraction of glass is 1.50, and we have this third angle to be what, 40.55. So that now we know that this will be 1.5 equals to sine of the fourth angle divided by sine of 40.55. Now, when we cross multiply, in this case, we're going to have 1.5 sine 40.55 equals to sine alpha 4. Okay, so let's get a value. So what is 1.5 sine 1.5, okay, multiply by sine 40.55. Now that will be 0.9712. 0.9712 equals to sine alpha 4. Now alpha 4 will now be the inverse sine of 0.9712. The inverse sine of 0.9752. Okay, it's 0.9752. Okay, 0.9752. Okay, so let's obtain the value for the inverse sine of 0.9752, and that will be 77.2. Okay, so this angle alpha 4, which is equals to 77.2, is the angle, okay, the ray leaving the prism, okay, mix with the normal, Remember, the noblest pleasure is the joy of understanding. Bye bye.